Welcome back. Let's read about this old fighter jet. F-18. Gonna need few minutes. Just need few minutes, not only 2 minutes, just eat this, and I need a little water. Will not take many minutes. Just eat one more bread. But we can drink this soda water. Because I have to move my arms so many times that the stop takes many minutes. I have to do this my whole day. No, I have to make so many movements, my arms, like a robot. But I have to do it because I'm not living at a hotel. I don't have my room service. I have to cook my own food and cleaning. This bottle, can I just put the bottle there because it will stay there always. I have to put it away in the plastic bag. And all this takes few seconds, and then it will be a few minutes. But now I'm ready. So let's read. It's 1 p.m. and I will make a kind of Danish video. It was supposed to be English. But I need half a minute to get to my bed. I have to check my cell phone. That's F-18. So let's read about it. I need my blanket.
McDonnell Douglas F/A-18 Hornet. F-18 redirects here. For the newer redesigned version of this fighter, see Boeing F/A-18E/F Super Hornet. For other uses, see F-18. The McDonnell Douglas F/A-18 Hornet is an all-weather supersonic, twin-engine, carrier-capable, multi-role combat aircraft, designed as both a fighter and attack aircraft, hence the F/A designation. Designed by McDonnell Douglas and Northrop, the F/A-18 was derived from the latter's YF-17 in the 1970s for use by the United States Navy and Marine Corps. The Hornet is also used by the air forces of several other nations, and formerly by the U.S. Navy's Flight Demonstration Squadron, the Blue Angels. The F/A-18 was designed to be a highly versatile aircraft due to its avionics, cockpit displays, and excellent aerodynamic characteristics, with the ability to carry a wide variety of weapons. The aircraft can perform fighter escort, fleet air defense, suppression of enemy air defenses, air interdiction, close air support, and aerial reconnaissance. Its versatility and reliability have proven it to be a valuable carrier asset. The Hornet entered operational service in 1983 and first saw combat action during the 1986 United States bombing of Libya and subsequently participated in the 1991 Gulf War and 2003 Iraq War. The F/A-18 Hornet served as the baseline for the Boeing F/A-18E/F Super Hornet, its larger, evolutionary redesign, which supplanted both the older Hornet and the F-14 Tomcat in the U.S. Navy. Development, edit. Origins, edit. Main articles, facts, Lightweight Fighter Program, and Northrop YF-17. YF-16 and YF-17 prototypes being tested by the U.S. Air Force. The United States Navy started the Naval Fighter Attack, Experimental, facts, program to procure a multi-role aircraft to replace the Douglas A-4 Skyhawk, the A-7 Corsair II, and the remaining McDonnell Douglas F-4 Phantom IIS, and to complement the Grumman F-14 Tomcat. Vice Admiral Kent Lee, then head of Naval Air Systems Command, was the lead advocate for the FACS against strong opposition from many Navy officers, including Vice Admiral William D. Hauser, Deputy Chief of Naval Operations for Air Warfare, the highest-ranking naval aviator. In August 1973, Congress mandated that the Navy pursue a lower-cost alternative to the F-14. Grumman proposed a stripped F-14 designated the F-14X, while McDonnell Douglas proposed a naval variant of the F-15, but both were nearly as expensive as the F-14. That summer, Secretary of Defense James R. Schlesinger ordered the Navy to evaluate the competitors in the Air Force's Lightweight Fighter, LWF, program, the General Dynamics YF-16 and Northrop YF-17. The Air Force competition specified a day fighter with no strike capability. In May 1974, the House Armed Services Committee redirected $34 million from the FACS to a new program, the Navy Air Combat Fighter, NACF, intended to make maximum use of the technology developed for the LWF program. Redesigning the YF-17, edit. Though the YF-16 won the LWF competition, the Navy was skeptical that an aircraft with one engine and narrow landing gear could be easily or economically adapted to carrier service, and refused to adopt an F-16 derivative. On the 2nd of May 1975, the Navy announced its selection of the YF-17. Since the LWF did not share the design requirements of the FACS, the Navy asked McDonnell Douglas and Northrop to develop a new aircraft from the design and principles of the YF-17. On the 1st of March 1977, Secretary of the Navy W. Graham Claytor announced that the F-18 would be named Hornet, after the characteristics of the hornet insect. It also shares the namesake with ships that had borne the name USS Hornet since the Revolutionary War. Northrop had partnered with McDonnell Douglas as a secondary contractor on NACF to capitalize on the latter's experience in building carrier aircraft, including the widely used F-4 Phantom II. On the F-18, the two companies agreed to evenly split component manufacturing, with McDonnell Douglas conducting the final assembly. McDonnell Douglas would build the wings, stabilators, and forward fuselage, while Northrop would build the center and aft fuselage and vertical stabilizers. McDonnell Douglas was the prime contractor for the naval versions, and Northrop would be the prime contractor for the F-18L land-based version, which Northrop hoped to sell on the export market. The F-18, initially known as McDonnell Douglas Model 267, was drastically modified from the YF-17. For carrier operations, the airframe, undercarriage, and tailhook were strengthened, folding wings and catapult attachments were added, and the landing gear was widened. Another wheel was added to the front landing gear as well. To meet Navy range and reserves requirements, McDonnell increased fuel capacity by 4,460 pounds, 2,020 kilograms, by enlarging the dorsal spine and adding a 96-gallon fuel tank to each wing. A snag was added to the wing's leading edge and stabilators to prevent an aeroelastic flutter discovered in the F-15 stabilator. The wings and stabilators were enlarged, the aft fuselage widened by 4 inches, 102 millimeters, and the engines canted outward at the front. These changes added 10,000 pound, 4,540 kilograms, to the gross weight, bringing it to 37,000 pound, 16,800 kilograms. The YF-17's control system was replaced with a fully digital fly-by-wire system with quadruple redundancy, the first to be installed in a production fighter. The airframe was designed for a service life of 6,000 flight hours. Originally, plans were to acquire a total of 780 aircraft of 3 variants: the single-seat F-18, a fighter, and A-18 attack aircraft, differing only in avionics, and the dual-seat TF-18, which retained full mission capability of the F-18 with a reduced fuel load. Following improvements in avionics and multifunction displays, and a redesign of external stores stations, the A-18 and F-18 were able to be combined into one aircraft. Starting in 1980, the aircraft began to be referred to as the F-A-18, and the designation was officially announced on the 1st of April, 1984. The TF-18 was redesignated F-A-18B. Northrop's F-18L, edit. Northrop developed the F-18L as a potential export aircraft. Since it was not strengthened for carrier service, it was expected to be lighter and better performing, and a strong competitor to the F-16 Fighting Falcon then being offered to American allies. The F-18L's normal gross weight was lighter than the F-A-18 by 7,700 pounds. 3,490 kilograms, via lighter landing gear, lack of wing folding mechanism, reduced part thickness in areas, and lower fuel carrying capacity. Though the aircraft retained a lightened tail hook, the most obvious external difference was the removal of snags on the leading edge of the wings and stabilators. It still retained 71% commonality with the F-A-18 by parts weight, and 90% of the high-value systems, including the avionics, radar, and electronic countermeasure suite, though alternatives were offered. Unlike the F-A-18, the F-18L carried no fuel in its wings and lacked weapons stations on the intakes. It had 3 underwing pylons on each side, instead. The F-A-18L version followed to coincide with the U.S. Navy's F-A-18 as a land-based export alternative. This was essentially an F-A-18 lightened by about 2,500 to 3,000 pounds, 1,130 to 1,360 kilograms. Weight was reduced by removing the folding wing and associated actuators, implementing a simpler landing gear, single wheel nose gear and cantilever oleo main gear, and changing to a land-based tail hook. The revised F-A-18L included wing fuel tanks and fuselage stations of the F-A-18O. Its weapons capacity would increase from 13,700 to 20,000 pounds, 6,210 to 9,070 kilograms, largely due to the addition of a third underwing pylon and strengthened wingtips. 11 stations in total vs 9 stations of the F-A-18O. Compared to the F-18L, the outboard weapons pylons are closer to the wingtip missile rails. Because of the strengthened non-folding wing, the wingtip missile rails were designed to carry either the AIM-7 Sparrow, 7F-7M-7P variants, same as the F-A-18O, or Skyflash medium-range air-to-air missiles, in addition to the AIM-9 Sidewinder as found on the F-A-18O. The F-A-18L was strengthened for a 9G design load factor compared to the F-A-18O's 7.5G factor. The partnership between McDonnell Douglas and Northrop soured over competition for foreign sales for the two models. Northrop felt that McDonnell Douglas would put the F-A-18 in direct competition with the F-18L. In October 1979, Northrop filed a series of lawsuits charging that McDonnell was using Northrop technology developed for the F-18L for foreign sales of the F-A-18 in violation of their agreement, and asked for a moratorium on foreign sales of the Hornet. McDonnell Douglas countersued, alleging Northrop illegally used F-A-18 technology in its F-20 Tiger Shark. A settlement was announced the 8th of April, 1985 for all of the lawsuits. McDonnell Douglas paid Northrop $50 million for rights to sell the F-A-18 wherever it could. Additionally, the companies agreed on McDonnell Douglas as the prime contractor with Northrop as the principal subcontractor. As principal subcontractor, Northrop produced the rear section for the F-A-18, a /B/C/D/E/F, while McDonnell Douglas produced the rest with final assembly performed by McDonnell Douglas. At the time of the settlement, Northrop had ceased work on the F-18L. Most export orders for the F-18L were captured by the F-16 or the F-A-18. The F-20 Tiger Shark did not enter production, and although the program was not officially terminated until the 17th of November, 1986, it was dead by mid-1985. Into production, edit. U.S. Navy F-A-18C during Operation Enduring Freedom in 2002. During flight testing, the snag on the leading edge of the stabilators was filled in, and the gap between the leading edge extensions, legs, and the fuselage was mostly filled in. The gaps, called the boundary layer air discharge slots, controlled the vortices generated by the legs and presented clean air to the vertical stabilizers at high angles of attack, but they also generated a great deal of parasitic drag, worsening the problem of the F-A-18's inadequate range. McDonnell filled in 80% of the gap, leaving a small slot to bleed air from the engine intake. This may have contributed to early problems with fatigue cracks appearing on the vertical stabilizers due to extreme structural loads, resulting in a short grounding in 1984 until the stabilizers were strengthened. Starting in May 1988, a small vertical fence was added to the top of each legs to broaden the vortices and direct them away from the vertical stabilizers. This also provided a minor increase in controllability as a side effect. F-A-18's of early versions had a problem with insufficient rate of roll, exacerbated by the insufficient wing stiffness, especially with heavy underwing ordnance loads. The first production F-A-18 flew on the 12th of April, 1980. After a production run of 380 F-A-18s, including the 9 assigned to flight systems development, manufacture shifted to the F-A-18C in September 1987. Improvements and design changes, edit. In the 1990s, the U.S. Navy faced the need to replace its aging A-6 intruders and A-7 Corsair IIS with no replacement in development. To answer this deficiency, the Navy commissioned development of the F-A-18E/F Super Hornet. Despite its designation, it is not just an upgrade of the F-A-18 Hornet, but rather, a new, larger airframe using the design concepts of the Hornet. Hornets and Super Hornets will serve complementary roles in the U.S. Navy carrier fleet until the Hornet AD models are completely replaced by the F-35C Lightning II. Although the airframe was originally designed for service life of 6,000 flight hours, the Marines have chosen to extend the use of certain F-A-18s up to 10,000 flight hours, due to delays in the F-35B variant. Design, edit. The F-A-18 is a twin-engine, mid-wing, multi-mission tactical aircraft. It is highly maneuverable, due to its good thrust-to-weight ratio, digital fly-by-wire control system, and leading-edge extensions, which allow the Hornet to remain controllable at high angles of attack. The trapezoidal wing has a 20-degree sweepback on the leading edge and a straight trailing edge. The wing has full span, leading edge flaps, and the trailing edge has single-slotted flaps and ailerons over the entire span. Canted vertical stabilizers are another distinguishing design element, one among several other such elements that enable the Hornet's excellent high angle of attack ability, including oversized horizontal stabilizers, oversized trailing edge flaps that operate as flaperons, large full-length leading-edge slats, and flight control computer programming that multiplies the movement of each control surface at low speeds and moves the vertical rudders inboard instead of simply left and right. The Hornet's normally high angle of attack performance envelope was put to rigorous testing and enhanced in the NASA F-18 High Alpha Research Vehicle, HALF. NASA used the F-18 HALF to demonstrate flight handling characteristics at high angle of attack, alpha, of 65-70 degrees using thrust vectoring vanes. F-A-18 stabilizers were also used as canards on NASA's F-15S/MTD. F-A-18C Hornet in transonic flight producing flow-induced vapor cone. The Hornet was among the first aircraft to heavily use multifunction displays, which at the switch of a button allow a pilot to perform either fighter or attack roles or both. This force multiplier ability gives the operational commander more flexibility to employ tactical aircraft in a fast-changing battle scenario. It was the first Navy aircraft to incorporate a digital multiplexing avionics bus, enabling easy upgrades. The Hornet was designed to reduce maintenance, and as a result, has required far less downtime than its heavier counterparts, the F-14 Tomcat and the A-6 Intruder. Its mean time between failures is 3 times greater than any other Navy strike aircraft, and requires half the maintenance time. Its General Electric F-404 engines were also innovative in that they were designed with operability, reliability, and maintainability first. The engine, while unexceptional in rated performance, demonstrates exceptional robustness under various conditions and is resistant to stall and flamiot. The F404 engine connects to the airframe at only 10 points and can be replaced without special equipment. A 4-person team can remove the engine within 20 minutes. The aircraft has a top speed of Mach 1.8 at 40,000 feet. The engine air inlets of the Hornet, like that of the F-16, are of a simpler fixed design, while those of the F-4, F-14, and F-15 have variable geometry or variable intake ram air inlets. A 1989 USMC study found that single-seat fighters were well suited to air-to-air combat missions, while dual-seat fighters were favored for complex strike missions against heavy air and ground defenses in adverse weather, the question being not so much as to whether a second pair of eyes would be useful, but as to having the second crewman sit in the same fighter or in a second fighter. Single-seat fighters that lacked wingmen were shown to be especially vulnerable. Operational history, edit. United States, edit. Entry into service, edit. McDonnell Douglas rolled out the first F-A-18 on the 13th of September, 1978, in blue on white colors marked with Navy on the left and Marines on the right. Its first flight was on the 18th of November. In a break with tradition, the Navy pioneered the principal site concept with the F-A-18, where almost all testing was done at Naval Air Station Patuxent River, instead of near the site of manufacture, and using Navy and Marine Corps test pilots instead of civilians early in development. In March 1979, Lieutenant Commander John Paget became the first Navy pilot to fly the F-A-18. Following trials and operational testing by VX-4 and VX-5, Hornets began to fill the fleet replacement squadrons VFA-125, VFA-106, and VMFART 101, where pilots are introduced to the F-A-18. The Hornet entered operational service with Marine Corps Squadron VMFA 314 at Marcos El Toro on the 7th of January, 1983, and with Navy Squadrons VFA 113 and VFA 25 on the 1st of July, 1984, replacing F-4S and A-7S, respectively. Navy Strike Fighter Squadrons VFA 25 and VFA 113, assigned to CVW-14, deployed aboard USS Constellation from February to August 1985, marking the first deployment for the F-A-18. The initial fleet reports were complimentary, indicating that the Hornet was extraordinarily reliable, a major change from its predecessor, the F-4J. In January 1985, the VFA 131 Wildcats and the VFA 132 Privateers moved from Naval Air Station Lemoore, California to Naval Air Station Cecil Field, Florida to become the Atlantic Fleet's first F-A-18 squadrons. VFA 151, VFA 161, VFA 192 and VFA 195 transitioned to the F-A-18 in 1986. With the exception of VFA 161, the rest would move to NAF at Suchai, Japan to join CVW-5 and the USS Midway. Other squadrons that switched to F-A-18 included VFA 146 Blue Diamonds, and VFA 147 Argonauts. The U.S. Navy's Blue Angels Flight Demonstration Squadron switched to the F-A-18 Hornet in 1986, replacing the A-4 Skyhawk. The Blue Angels performed in F-A-18 B, C, and D models at air shows and other special events across the US and worldwide before transitioning to the F-A-18 E/F Super Hornet in late 2020. Blue Angels pilots must have 1,250 hours and an aircraft carrier certification. The two-seat B and D models were typically used to give rides to VIPs, but also filled in for other aircraft, if such a need arose. NASA operates several F-A-18 aircraft for research purposes and also as chase aircraft. These F-A-18s are based at the Armstrong Flight Research Center, formerly the Dredon Flight Research Center, in California. NASA received 3 two-seat F-A-18B aircraft in 2018. On the 21st of September, 2012, 2 NASA